All right, everyone. I'm going to turn on my video. Hello, and welcome to the 2022 Research Symposium. So I'm going to start by just giving a quick, introduction to the event that we're about to have, and then I will hand it over to our wonderful keynote speaker and presenters. So just a few quick things. So what I thought I would do is to start by kind of explaining, the context of today's event, where we are going to have, a really nice number of middle school and high school students presenting various research projects that they've done. And so to provide some context, what is this research activities that we are referring to? How do they work? And generally, how would you want to think about maybe if you wanted to do something like this? How might you go about it? So, first, welcome to all of our attendees and presenters, and a big thank you to everybody who worked so hard, particularly the presenters who worked really hard to put their presentations together. So a little bit about, our organization. So AIClub is an organization that provides AI literacy for K-12 and beyond. We educate a lot of K-12 students, teachers on AI literacy and how to bring AI into the classroom. And we also educate a fair number of professionals on various, ways to do production-grade artificial intelligence. We've been around for about 2.5 years now. This is our second annual research symposium. We've taught a few thousand students, but I think more importantly, our students have built a really impressive array of AI-powered applications, and they have been able to have impact in many different areas that you'll see in the presentations today. And those impacts have led them to, I believe at this point, over 54, not 54, but probably a little over 54 national and international competition wins that range from everything from application related challenges to research challenges to professional research conferences where some of our advanced students present their work. So these are the kinds of things that, that we have found that AI literacy can empower students with. And so before we get kind of going on our student presentations, I just want to give a little bit of context into when we say research symposium, what do we mean? And what is this research that we're talking about? So generally, sometimes people associate research with the PhD programs or with graduate students or something super advanced. But at the end of the day, research is fundamentally an organized way of thinking about a real world problem. So the idea is that you want to try to define the problem fairly well. You want to figure out what you know about it, what you don't know about it, form a hypothesis, an opinion of what you don't know, and then try to figure out whether or not your opinion is correct or not with evidence. So, when you think about it that way, I mean, this is part of how you solve problems in life. And one of the reasons why we are so passionate about young people, doing research at an early age is because this is not necessarily about getting a PhD. This is just about organizing your brain. And the idea that you can, look at a problem, think about how you want to phrase the problem, find information about it, see what that information is telling you, run an experiment if you feel like running an experiment. These are good skills to have. And so what we have found is that this is the kind of thing that we really look for in, and we're, that you'll hopefully see in some of the presentations today is how these students went about defining, structuring, gathering data, and solving their problems. So why is this helpful to learn? Fundamentally, it is the scientific method at heart. And the scientific method is not unique to AI. It is something that, we apply everywhere and not always just in science. Yes. So this is how the world solves problems. This is how you learn to think and organize your brain. This is how you kind of, basically can approach problem solving skills and also make solid arguments for your opinion. And making arguments with data is, I think, something that people is really, really helpful to know. There's so much data out there these days, and being able to learn how to make your arguments with data, understand what the data is telling you, is simply a very useful real life skill. So, now, what is the opportunity that this presents, particularly to middle school and high school students? So there's a tremendous amount of public data available now, and it's really mind-boggling just how much public data is actually available. And so you can start with the obvious source, which is the internet, and you can, Google for anything, and you can scrape data and gather pictures and gather, statistics and things like that. But it's not just that. Like just a simple random, information, there are an enormous amount of medical data sets available out there that, some of which are just completely public and some can be acquired with, simple application. The Centers for Disease Control publish an enormous amount of data about health and the United States population. There are public satellite images that are constantly scanning the earth, looking for everything from wildfires to floods to to cloud formations to anything like that. Closer to the ground, there is drone imagery that you can use for all sorts of things. And so part of this is that because of the confluence of the internet, as well as the increased reliance on data, there is really a tremendous amount of public data available. So what does that mean? What that means is that it gives, with the right, learning, you can have the opportunity to really study a problem, and learn a lot of interesting things about it from nothing but public resources. So it's really helpful to know what these public resources are and how you might go about processing them and organizing them and seeing what they tell you about a question that you're interested in. So what can students do? They can use this kind of information to analyze problems, to test out solutions, to build apps and things like that. And I'm not going to say much more about this because I think the student speakers will demonstrate for the directly the kinds of things that they have done. The vast majority of the presentations that you will see today were done on public data. However, it's also important to know that if you learn how to analyze public data, you can be a huge help, in an internship, for example, to help organizations analyze their own data. And so they can add a lot of value and contribute a lot that way as well. And so you can use the public information to learn how to think about data, and then you can apply what you've learned to data that may not even be public. So what is this typical process? So the typical process is things like, you brainstorm problems, you try to find an area that is interesting to you, you think about what might be a good, interesting problem, you look for data, you look for what people have done before, you create a working hypothesis, and then you evaluate that hypothesis. You assemble what you learn about it, you study your results and see, okay, what did the results actually tell me about this problem? And then you want to share it with other people. So that life cycle is really important. So it's not just about sort of, creating a hypothesis, but it's also about the scientific method of learning how to evaluate your hypothesis in a way that you can feel like, okay, you know what, I did my science correctly, and so I can trust my conclusions. And then being able to explain your conclusions to other people so that they can learn upon it. So this is what it means to kind of advance the state of the art. And I think one of the really nice things, about, the resources available to students today is that it is actually very possible for them to apply and add value to an interesting problem because so much data and so much computational resources are available to them. So where does AI fit into all of this? So AI is in some ways, useful for this process because it's a technology that helps people understand data. And so if you think about the scientific method, defining a problem, doing a hypothesis, proving your hypothesis, that is not about AI. That's just the way that you solve problems, and you can fully do research and do the scientific method without any AI at all. AI makes life interesting because it is a really good match for the massive amount of data out there. And so if you do, if you're looking to do a research project, and you don't have access to a wet lab or, a place where you can run experiments and things like that, then, using public data and using computational resources like your own computer or something in the cloud and using some AI is a really good way to create an interesting hypothesis and evaluate it without ever stepping foot in a lab. And so not just because of COVID, where now we have difficulty with any physical location, but for safety reasons and other things, it's quite difficult to get access to an actual physical lab. But you can do some amazing stuff, as you'll see with some of these students, without ever leaving your desk. And so that, I think, is the reason why AI fits really well in, and it works really well with real data. So what these charts here actually are about 2 years old. This year is even more, impactful in this regard. But what we are seeing is an increased amount of AI use in science fair projects. So these are statistics from the Synopsis Science Fair, which is the spotlight science fair for this for the Southern Bay Area, where a lot of technology is developed. And you can see two things. One of them is that the presence of AI in winning projects is actually going up year after year. I don't have the data here listed, but 2022 was even higher. The other thing you can see is that the spread of grades that are using AI is changing. In 2021, in 2020, AI was really more in the higher grades. Now it's starting to show up even in the lower grades. The reason for this is that the opportunity is becoming clearer. And the fact that these tools are available and that they are not that hard to use is making it possible for very young people to really think about interesting problems and be able to have access to tools that will help them think about their problem, learn more about it, come up with conclusions, things like that. So what are we going to do today? So today's event is an annual event, and it involves a keynote speaker and a number of student presentations. This year's keynote will be given by Dr. Oza. I will give him a formal introduction in just a little bit, and he will be talking about how AI is used in NASA. Our student presentations, we have 9 student presentations from middle school and high school students. And they have done projects in really wide-ranging topics. Our first talk will be in astronomy about nebula detection and classification of planetary nebula. We have a number of talks in the general STEM, medicine, health area, a couple of talks in the environmental space, some social good, and sports technology. Across these talks, they have used lots of different kinds of public data and some private data as well. And they have used all sorts of different AI technologies that I'll let the students talk about themselves. And across the board in software as well, they have used lots of different types of software. Most of these projects were running in the cloud, but they used deep learning, Python, R, Swift, and a variety of other things. So that is what we will do today.